Okay, so this is part two. So hopefully now you've got the idea of looking at this number line. Let's extend it a bit further, because before we did, on this one here, we did finding the probability that x is smaller than or equal to 3 by doing probability that x is equal to 1 plus x equal to 2 plus x equal to 3, which is fine, but if I now gave you a much greater number, so work out the probability that I roll a 6 in less than or equal to 20 attempts, that's a lot of adding up that you're going to have to do. You'd have to do probability that x is equal to 1 plus 2 plus 3 plus 4 all the way up to 20. And so that's really inefficient, and it will take you a long time, and there's probably likely to be an error somewhere. So we need to think about another way of calculating larger numbers like this. So you could do it for x is smaller than or equal to 20. It would take you a long time. But imagine if I asked you to work out the probability that you rolled a 6 in less than or equal to 327 rolls. You really couldn't do that by a number line. So let's have a think about another idea. So going back to the number line approach, so x is smaller than or equal to 20. So I've sort of drawn out my number line. So we've kind of got this cut-off point here, haven't we? So here we've got the probability, all of these ones here are that I roll a 6 in 20 or less attempts. So any one of these would satisfy this inequality. Everything to the right of that, therefore, is I roll... would be the probability of rolling in more than or equal to 21 attempts. So if you remember, so all of this needs to add up to 1. So from using the idea that we had before, so sort of this part of what we had a look at before, so in particular this rearrangement here. So I'm just going to simply... because these two need to add together to make 1, then the probability of x is less than or equal to 20 is going to be 1 minus the probability that x is greater than or equal to 21. Okay, so that's just a simple rearrangement of this. So if I can work out what this probability is, then simply by subtracting it from 1 I can work out what this probability is. So let's have a think about this idea here. So this is asking, what is the probability it takes 21 or more attempts to get a 6? That is what this is saying. So let me just repeat that. It's asking, what is the probability of it taking 21 or more attempts to get a 6? Or think about it, how can I guarantee at least 21 goes to get a 6? Well, I have to have 20 failures to get, so let's just think about that. So if my probability here is what's the probability that it takes me 21 or more attempts to roll a 6, that must have been that I have got 21 failures. As long as I've got 21 failures, then it will take me at least 21 goes to get a 6. So I need to work out what is the probability. So what is the probability of 20 failures? Well, the probability of 20 failures must be 5/6 to the power of 20. So that is what is the probability of getting 20 failures. So therefore, the probability that x is greater than or equal to 21 is the probability of getting 20 failures. So therefore, if I go back to this idea here, so the probability that x is smaller than or equal to 20 is 1 minus this probability here. So that must be 1 minus 5/6 to the power of 20. So this probability here is going to be 1 minus this probability here. And what is this probability? Well, this is the probability of 20 failures. So this is a summation of all of these probabilities here. All of these probabilities here have summed to give me this probability here. So kind of keep going back to that idea, as long as you've got 20 failures, as long as you've rolled 20 not 6s, then it is going to take you at least 21 attempts to get a 6. So therefore, if I can work out the probability of 20 failures, which is that, then it must be that any rolls after that, regardless of if it's a failure or a success, then it must have taken me at least 21 goes. So that's quite a complex idea to get your head around, but let's kind of just double check this with this original one that I did here, just to make sure that it works. So I said that the probability of getting less than or equal to 3 was this, and I did it by summing the 3 different options. So that was quite an easy way of doing it. So let's just think about this in terms of this idea here and making sure that this equation works. So I know the probability that x is less than or equal to 3, I worked out as that from this part of the presentation here. So from the equation that I've been using here, so let's just keep that there. So the probability that x is smaller than or equal to 3 is equal to 1 minus my failures to the power of, what would it be to the power of? Well, if it was less than or equal to 20, I put it to the power of 20. So if it's less than or equal to 3, then I put it to the 3 there. So if you do that on your calculator, you will find that you get exactly the same answer, showing that this equation here works. So when we're talking about the idea of equations, so let's just have a think about what the general equations are. So these are important equations to know. So if you are asked to work out the probability that x is, let's do it the other way, x is smaller than or equal to some number, x, so that is going to be 1 minus the probability of failure to the power of x. So that was just like what I have done in this one here. Okay, so the probability that x is smaller than or equal to 20 was 1 minus the probability of failure to the power of 20. Another way that I could have written this is 1 minus p, because that's what q is, isn't it? To the power of x, because of this idea. Okay? So that's one general equation. The other general equation, so the probability that x is greater than or equal to some number, x, so that is going to be q to the power of r minus 1. So what do we mean there? Well, when we looked at this one here, the probability that x is greater than or equal to 21, well, that was when I had 20 failures. So that was 5/6 to the power of 20. So the probability that x is greater than or equal to some number is the probability of failure to the power of r minus 1. Or I could write that as 1 minus p to the power of r minus 1. So hopefully that will clarify in your mind what we mean about the when we're working out questions like this with the geometric distribution. I always think kind of going back to this number line idea is a really good idea, and sort of sectioning off, well, what part of the number line do I want and what part is sort of supplementary. So in this question here, I wanted smaller than or equal to 20, so I drew my number line out and I drew a bar down at 20, and everything else was supplementary to that. This idea that they all add up to 1, so I could write the equation that that plus that equals 1, and then I get a rearrangement. And if you can appreciate the idea that this probability here, whatever this number is, 21 in this case, how do I definitely get 21 rolls? I must have to have 20 failures. And therefore, you get this idea here. And once you've got this idea, then you can simply plug it back into the equation to get this probability here. So these are just general formula for this idea here. So if you can understand this idea, then you should be away with the geometric distribution. Just one more thing. So let's just have a quick look at this idea. If you were asked to work out the probability that x is greater than 9, well, on both of these equations here, well, on this one in particular, because it's greater than, I put greater than or equal to, and that's the formula for greater than or equal to. But just think a bit about it in a different way. So probability that x is greater than 9 must be 10, 11, 12, 13, 14, and so forth. So it includes 10 and upwards. So instead of thinking about it as x is greater than 9, just think about it that x is greater than or equal to 10. And then you can, if you draw out your number line again, so here, so this is a probability that x is greater than or equal to 10. And so therefore here we have probability x is smaller than or equal to 9. Or think about it the other way around. If you have the probability that x is smaller than 5, so that's kind of that associated equation, but here it's x is smaller than or equal to some number. So x is smaller than 5, so that it would be 4, 3, 2, 1. So just think of it as x is smaller than or equal to 4 instead. So draw out your number line, and then so it's here, isn't it? Probability that x is smaller than or equal to 4. And here is probability that x is okay. So if you get these two slightly different ways of writing it, just try and think about it in a different way, so that then you can go back and use this general formula here. Okay, so there's going to be a question now which I'd like you to get on with about using these ideas here, and then you're going to go to the textbook and do some questions here. So I hope you found this video helpful, and any problems, questions, please ask.